Okay, let's start. All right, so is this clear now? That's just national income accounting at work. So now let's get growth. What we're going to do now, we're going to get growth out of it. We're going to get balanced growth. Okay? Balanced growth. So the topic is, how do we get growth with constant technology? What does balanced growth mean? Okay? Why economists keep talking about balanced growth and doing models of balanced growth when balanced growth does not exist and never existed? Why are we obsessed with balanced growth? There are reasons. Some bad, some are due to our limitations. And then we're going to understand something else. We're going to say Solo. 1956. Why everybody talk about Solo? I'm going to ask you a question. Have you read Solo 1956? Is it part of your reading list? How many people have read Robert Solow paper in the, I think, Quarterly Journal of Economics in 1956? How many? Nobody. Good. That's good you said nobody. And we're going to have a few surprises. Okay? And then we'll finish the class with a question, which we will address next Tuesday. And the question is, what's the contribution of the so-called new growth theory to all this? And I will try to explain to you that the contribution has been negative. We just wasted time and made a gigantic confusion. But somebody got a Nobel Prize. Okay, growth. So how do we get growth out of it? Well, here you see, right? So the economy starts with X0. That's the stock of inputs. Humans, cows, land, geese, chickens, all kind of things. Rooms, electricity, power, water, humans, beasts, anything. That's the whole list. And it's got two matrices, A and B. Right? X0 is enough to carry out production at level lambda 0. So that's what they do. Now notice immediately one thing. There is going to be idle resources. Right? Do you understand what idle resources mean? At any point in time, you take a random economy with a random allocation of resources and you make it adopt a technology A. So think China, 1980, just to stay home, right? When investments come from abroad, new technologies get adopted. So production starts to go on and say, what's going to happen? Because there are fixed coefficients in the short run, some stuff here will not be used, will be redundant. In fact, you had millions of farm workers that were redundant. Millions. Not one or two. Tens of millions. Whereas other type of workers were very scarce. Engineers, managers, chemists, right? Financial officer, whatever. But this is true for China, it's true for every country. Right? So only in a magical world you have this, full employment. Okay? Good. So this time that produces Y1. Y1 is consumed and a part of it is saved. How much? Well, enough to carry out tomorrow production at level, to carry out production at level lambda 1. Technology is constant. There's no innovation here. This is a constant technology. Okay? Right? That produces the vector y2 that's split in c2 plus x2. And so on. So when is that there is growth? There is growth if yt plus 1 is larger or equal than yt for all t with strict inequalities sometimes. Well, many times, in fact, infinite number of times. Right? Then we say the economy grows. Now here, I have to give you a bunch of theorems. Without proving it, there's no time. I was mentioning, Young, that there is a beautiful article you can find by Chialin Koopmans. He deserved this Nobel Prize. It's called On the Concept of Optimal Economic Growth. It will give a detailed explanation of this. Okay? You can find it online. All right? So how do we get growth? As you notice, we get growth if all factors that are essential in production are also reproducible. Because the technology is constant. So you cannot, under this model, so with a constant technology, without innovation, you cannot substitute one good for another, right? So everything that is necessary for production has to be reproducible if you want to grow forever. If something that is necessary in production is not reproducible, then you stop when you reach that level. You understand that that was the Malthusian view. If you want to understand the classics, this is the classics. Smith, Ricardo, Malthus, right? Technology is more or less constant. When some factors are abundant, we employ them. But then some factors become scarce. In their view, land, usable land, arable land become scarce. There was no way of extending it, no way of improving it. Hello? And therefore, eventually, because land became scarce, there was no way of growing. You would reach a steady state. Okay? What's a steady state here? A steady state is a situation of no growth. A steady state is a level lambda star such that A lambda star equal X star, B lambda star equal Y star equal X star plus C star. That's a steady state in this model. Right? Production always takes place at the same level. Right? Consumption is constant. Employment of factors is constant. Stock of capital is constant. Output is constant. This will happen under two circumstances. One, there is some fixed resource that is necessary in production and is limited. Once you have reached full employment of that resource, that's it. Okay? No reason to accumulate other resources anymore because they're not useful. You consume them and you reach a steady state. All right? Case number one. Case number two. The economy is not expansive. You see, I wrote this, but this is not obvious. So this is actually the difficult theorem to prove. It's not obvious that all technologies are like that. Some technologies do not allow for extra accumulation. Some technologies just barely allows you to survive at a certain level of consumption and reproduce the capital stock. So maybe, even if there is no natural resource that bounds you, you're just not productive. You see what I mean? There's no magical law that says every technology has to be capable of giving more output than inputs are put in. Many rural societies, many stagnant societies, were not stagnant for Malthusian reasons, but were stagnant because the technology was not productive enough. I think the one, for a long time, the Chinese one was, but many societies have plentiful land, plentiful space, but there was no growth because the production technology did not allow for surplus. And therefore extra reproduction and other factors and utilization of land and so on. Okay? So it's perfectly possible to have stagnation just because the technology has, it's not expensive. The literature in growth theory post von Neumann studied this quite carefully. It's a lot of papers on that. Von Neumann proved the beautiful theorem with this model, using Perron-Frobenius and a fixed point argument for the first time. He proved that when all essential factors are reproducible, okay? So all essential factors are reproducible means there is no essential factor that is non-reproducible and bounds growth. And the technology is expansive, and he proved that that amounts to having the eigenvalues of the matrices A and B such that they satisfy a certain inequality. Okay? And that's where the Perron-Frobenius argument came in. Okay? Well, when the technology is expansive, then there exists balanced growth. So what's balanced growth in an economy like this? Imagine, it's an economy with a constant technology, which means it's always the same commodities, always the same capital inputs, the same things, right? It's not an economy where things change. Things change only in quantity, not in types. So balanced growth means that there is a vector of input that has the following form: x1 star, x2 star, xn star. And these ratios, the ratio between the first input and the second, the first input and the third, the first input and the fourth, and so on, right, are constant over time. So that the vector xt is actually 1 plus g at the power t x star, where g is a scalar larger than 0. That's the balanced growth rate. Right? Balanced here means in the sense that there is a constant balance among cow type 1, horses, shoes, houses, pigs, etc. Okay? And obviously, if that's true, then also there is a vector of this type such that this is true. Right? Output also grows. Right? Also the vector of output has always the same composition, and it just grows in size. But the composition is the same. And obviously there is a vector then of consumption that does the same thing. Okay?
The growth rate of consumption, capital, and output must be the same.
Yes. They are the same, right? They cannot be different. Think about it.
It's not different.
Think.
It's different, and some will explosive.
Right. Right? If they're different, because they have to aggregate, they have to be complementary. So, either the capital stock grows too much and consumption does not, or vice versa. But because of constant return, that's not possible. Because production, remember, production basically grows. This is the thing that determines everything, right? If I have this vector in the first period, I get a certain output, right? If now I use 10% more, what do I get? 10% more because of constant returns. Right? And therefore, tomorrow I have exactly 10% more of everything. And therefore my consumption has to grow 10% more. Right? Because if now I change, my consumption grows only of 9% and my output grows, my input grows of 11%, then output grows of 11%. Right? So that's balanced growth. Von Neumann shows that under assumption, basically there are assumption of irreducibility of the economy, that is, all necessary inputs are reproducible, so the economy is reducible from that point of view. And productivity, that is, the economy is not unproductive, this thing exists. It's an implication of constant returns, basically. Is it clear? Balanced growth. So in a balanced growth economy, there is no technological change, right? Consumption grows, but it's always in the same composition. Output grows, and it's always in the same composition. And the inputs grow, but they're always the same composition. This also means that prices are constant, because people always do the same thing. A constant growth economy, balanced growth economy, is an economy that expands symmetrically. Imagine a balloon with complicated figures that expands spherically at a constant rate because you're just inflating it. But the shapes that you see are always the same, just bigger and bigger and bigger and bigger and bigger. Notice also that this allows you, did you understand? So if you look, and we will not study this, but if you're curious, this was a result known in the literature before World War II. Okay? After World War II, some of this stuff was used during the war to try to compute input requirements. There was a big development of input-output analysis because of that, and so on. After the war, in the late 40s and 50s and 60s, many people tried to use this, many countries, including yours, and Russia in particular, tried to use this to do planning, not understanding that this was a description and not a normative thing. Not understanding Hayek thing, if you want this thing to work, you have to know all the information. N is very big. You have to know all the N. You have to know all the inputs. You have to know how to improve them. That's not something you can do from the central office. And so there was that use. There was a bit of a failure. Actually, it was a huge failure. Okay? But then there was also a theoretical study of this. And one of the problems that people asked was, okay, assume you have an economy with constant technology that therefore has a balanced growth path like that. If the balanced growth path is at a constant rate, I can try to normalize everything by dividing everything by 1 plus g at the power t, right? So it looks like a stationary economy that is just growing at a balanced rate. If I start from an arbitrary initial condition, from an arbitrary stock x0, different from x star, there's no reason that you start from x star, right? History may give you an initial condition completely off that, right? Remember, because this has the right composition, right? It says the right number of engineers, right number of cows, right number of chicken, right number of bulls, you know, all right, everything is right. There's nothing too much. Everything is right to grow at that balanced rate. This may have too many of one thing and too few of another. So for a period, you